Okay, so our first one, we're going to cross the river and we're going to go straight across. Okay, the river is how far across? 120. The boat is pointed straight across. 3.5 meters per second, is that how fast, right? The current is downstream 1.2 meters per second. And we want to find the time to cross, where it lands, and the velocity as seen from above, or the speed or something like that, right? Okay. So the good news is that all we have to do is this. We're going to have a cross, and we're going to have downstream. So across is that way, downstream is that way. We have x, we have v, we have t, and that's it. No a. The rivers are not going to accelerate. Okay. So what do we know? As we point straight across, as we move, try to move straight across, what do we know in this thing? Ryan's got some.
The velocity across is 3.5.
Indeed it is. Yeah, we're pointed straight across, and so that's easy, right? We're moving straight across at 3.5. What else do we know? Max has got some. Yeah, right. So 1.2 is our velocity downstream. What else do we know? Distance is what? Distance across is 120. There we go. And now we're set. You used to have 3 things, but with just distance, velocity, and time, we only need 2 things, right? And so I can find the time here. Time is distance over velocity, right? So it's 120 over 3.5. Yeah. 120 divided by 3.5. Yeah, 34.29 is close enough, right? Right, can I move the time across? Indeed I can, yes. Okay, how are we going to find out how far downstream we drifted during that time? Will you just multiply them? Yeah, this times this, right? Yeah, so x is v times t is what I'm doing, right? And in general, the formula is just v is x over t. It's the first one we learned on the first day of class. That's all we ever do, right? So this guy is going to be 34.29 times 1.2. So I'm going to multiply by 1.2. I get 41.14. Right, so it's 120 meters across. We're actually going to land a third of that way, sort of downstream, right? 41.14 meters. Okay. As we cross, the time it takes to cross is 34.29. That's one of the questions. We drift 41.14 meters downstream. Okay. And as we cross, our velocity looks like this: 3.5 across, 1.2 downstream. So what's the speed? What is our actual speed as being a combination of the current and our own velocity? How would we find the speed? Using a coded term here, also known as the hypotenuse of the velocity vector, right? What is that? Figure that out. Figure out that hypotenuse. It's going to be the square root of 1.2 squared plus 3.5 squared. Yeah, it's exactly 3.7. That's just crazy. How could it be exactly 3.7 meters per second? Because it's a 1.2, 3.5, 3.7 right triangle. They don't all have to be like, 3, 4, 5 or something like that, right? Are we good? Could we figure out this angle too if we wanted to? I don't feel like it, but it would be inverse tan. That angle there would be tan minus 1 of 1.2 over 3.5 if we wanted to figure it out. And then we know everything about it, yes? Wouldn't we feel smart? So that's the easiest one to do. These are called boat crossing river problems. Most of them are like this. Okay, in the middle I'm going to do the hardest one, and then it's going to get easier. Okay? So we'll divide it up, right? So the next thing to do is to try just pointing the boat at some arbitrary angle. Okay, so now we're just pointed at 32 degrees. This is 32 degrees is not the angle that makes it go straight across. Rather, I think we're actually going to overcompensate and go upstream. So let's draw a picture of this. Now we're pointing our boat at some angle like this, 3.5. This is 32 degrees. Right, like that. And across and downstream, and X and V and T, X and V and T. What do we have to do likely with 3.5 meters per second at 32 degrees? We got to do the cosine and the sine, don't we? Right? Remember, if you get one of those angles like that, right? Okay. If you get one of those angles, always break it into the components first, and then say, "Gee, I don't know what to do." Right? So this side here is 3.5, and that's 32 degrees. So 3.5 cos 32, and then this side here is 3.5 sine 32. Take your calculator right now and do that, because there's nothing else to do. And we still have a current of 1.2 meters per second acting down, or going downstream, right? Are we good? Do you guys get like 2.968 and then 1.855? Okay, so now let's put them in the little across and downstream and see what happens. So who's got something that goes somewhere? Where does the 120 go, the width of the river? You guys are staring at me like I can't do this. That's a cross for X, right? 120, it's still 120, right? There she is. What do we do with the current? What is the current? 1.2, and where does it go? It goes downstream as a velocity, right? So 1.2 meters per second, right? What do we do with the 2.968? Is that V across? Yeah, it's V across, right? Yeah? What do we do with this component right here, the 1.855? What is that? Is that upstream? Hold on. I might answer your question here in a sec. What do we do with the 1.855? Did I get it wrong? I got it right. Because it's down. Oh, X. Oh, yeah. Smart Alex. What do you think you'd... What do we do with the 1.855? You got it. You're thinking about it, but it's too risky, right? Isn't it in the same thing, right? Yeah. Isn't it actually minus 1.855? Oh, okay. Right? Because they're in opposite directions. Current is downstream, which is positive, and upstream must be negative then. That's kind of a crazy thing to do, right? So isn't upstream negative downstream? Yeah. This is crazy physics land, right? Only a physicist would say go negative east. This is the negative east coast. No, it's the west coast, right? They're the negative west coast over there. Okay. So what's the net effect in the downstream direction? Isn't it that we're going upstream at 0.655? Got to cut out a little piece here, right? So it's negative 0.655. A little piece of the river is cut out like that, right? Okay. Are we set? We can solve this now, can't we? Okay, so we can figure out the time. The time is going to be more, so 120 divided by 2.968, 40.43. Right, time goes across. And then how do we figure out the x? Do we use the 1.2 times this, the 1.855, or the sum? Yeah, the 0.6, right? Okay, so the x is going to be 40.43, the time, and this is how fast we're going upstream. Right, I'm going to put